Hello, this is Mr. Miller, and welcome to video 2B, you lucky people. We're going to talk about comparing fractions. All right? So the first thing we want to talk about is the idea of equivalent fractions. Equivalent fractions are fractions that represent the same quantity. If you look at these six figures here, the same part is shaded in all of them, but they can be represented with different fractions. For instance, in this first diagram, we have 3 equal parts, and 2 of them are shaded. So the fraction shaded is 2/3. Here, 4 out of 6 is shaded, so that's 4/6. But it's the same amount. If you look at the diagrams, it's the same amount of shading. So it turns out that 2/3 and 4/6 are equivalent fractions. All right, here it looks like we have 12ths. We have 8 out of 12 shaded. That's equivalent to the first two. And on this one, it looks like 1, 2, 3, 4. We have 24ths, and 16 of them are shaded. So we have 16 24ths is equivalent to 2/3, 4/6, and 8/12. All right, this is getting a little crazy, but I think we have 32 out of 48 shaded here. That's equivalent to 2/3 also. And here we have 6 out of 9. So all these fractions represent the same amount. They're all equal. We could say that 2/3 equals 4/6 equals 8/12. It's the same thing as 16 over 24. But we could write it as 32 out of 48, which is also equal to 6 out of 9. All these fractions are equivalent ways of representing the same quantity. Okay, here's another example. In this first diagram, we have 2 out of 4 squares shaded. Simply, it's equivalent to a half. Here it's divided up into eighths. We have 4/8. Okay. On this one, we have, it looks like 8/16. It's equivalent to the first two. And finally, on this one, it looks like we have, let's see, 16, 16, 32 out of 64, I believe. Okay, so 2/4, 4/8, 8/16, and 32/64 are all equivalent. So they're all actually equivalent to a half. It turns out that if we have a fraction like a half, if we multiply the top and the bottom by the same number, we get an equivalent fraction. So 1/2 times 2 over 2 is 2/4. That's equivalent because multiplying by 2 over 2 is the same as multiplying by 1. Okay, so that's why we end up with a fraction that's equal to the first one, because we were really multiplying by 1. We just get a fraction that looks different but represents the same thing. We could have also then say like 1/2 times 8. If I multiply by 8 over 8, I would get 8/16, which was this one. So as long as you multiply the numerator and the denominator by the same thing, or divide them by the same thing, we get an equivalent fraction. It's the same as multiplying or dividing by 1. All right, so we're going to generate a bunch of equivalent fractions here. So what we're going to do is we're going to start with a fraction like 3/10, and we're going to multiply both the numerator and the denominator by the same thing. We can multiply by whatever we want, but I'm going to pick 2. If we multiply top and bottom by 2, we get 6/20. Okay, that's equal to 3/10. What if I multiply the original fraction by 3 over 3? 3 times 3 is 9. And the denominator, 10 times 3 is 30. That's equal to 9/30, not 36s. If I multiply the original fraction by 4 over 4, we would get 12/40. If I multiply it by 5 over 5, we get 15/50. If I multiply it by 6 over 6, I would get 18/60. We can multiply it by any number in the numerator and denominator and get an equivalent fraction. All these fractions are equivalent. Let's do the same thing here. Let's multiply 5/2 by 2 in the numerator and denominator. So this would be 10/4. Let's multiply the original fraction by 3. That would be 15/6. If I multiply it by 4, that'd be 20/8. If I multiply it by 5, that'd be 25/10. If I multiply it by 6, we'd have 30/12. All of these equal fractions. Right here, we want to find the missing number. We just got to think about what we multiplied. To go from 4 to 12, we must have multiplied by 3. So we're going to multiply by 3 here. And it turns out that 4/7 is equal to 12/21. All right, 7 times 3 is 21. All right, here, 8 times 2 is 16, so we must be multiplying by 2. 7 times 2 is 14. So 7/8 is equal to 14/16. 7 times 3 is 21. So what times 3 is 30? 10. We have 7/10 is equal to 21/30. Now, we'll see why getting equivalent fractions is important when we do addition and subtracting fractions. We'll need that a lot. But this also appears when we're reducing fractions. Reducing fraction means writing it as the simplest fraction that equals that quantity. And usually this involves division. It involves dividing the numerator and denominator by the same number. So we got to think, what can the numerator and denominator be divided by? Well, here we have 3/6. So we got to start thinking. 2 goes into 6, but not 3. We could divide both by 3. 3 divided by 3 and 6 can be divided by 3. So when we divide the numerator and denominator by 3, we get 1/2. Turns out that 3/6 is equal to 1/2. That's the simplest form. So sometimes we'll find something that goes into both the numerator and denominator. We'll get a simpler fraction, but we'll realize we could keep going. All right, 14 and 18, we can divide both of those by 2. 14 divided by 2 is 7. 18 divided by 2 is 9. And I look, can I divide it by something else? It turns out no. There's not a number other than 1 that goes into 9 and 7. All right, let's look at 12/16. I'm sorry, 12/36. 2 goes into both. So 12 divided by 2 is 6. 36 divided by 2 is 18. We can keep going. We can still divide by 2. So that's equal to 3/9. Both of those can be divided by 3. That's equal to 1/3. So I deliberately did it step by step. Maybe you realize that 12 goes into both these numbers. 12 divided by 12 is 1. 36 divided by 12 is 3. Maybe you could do it in one shot. My point is, though, if you take smaller steps, that's fine. Just keep going until there's nothing we can divide the numerator and the denominator by. 21/63. Now, let me share a little secret. Usually, I try dividing by the prime numbers. I try dividing by 2, 3, 5, 7, and usually I don't need 11, but I usually start by trying to divide by one of these numbers and see if they go in both. So 2 doesn't go into 21 and 63, but 3 does. So 21 divided by 3 is 7. 63 divided by 3 is 21. Well, I can keep going. These both can be divided by 7. So 7 divided by 7 is 1. 21 divided by 7 is 3. Turns out that 21/3 is equal to 1/3. So these numbers are very useful. So instead of just randomly trying anything, try the prime numbers, the first few prime numbers. I think if you try those, you'll be able to reduce any fractions that we're going to do. All right. So we want to move on a topic to comparing fractions. So we want to know, is the first fraction less than the second fraction? Is it equal to the second fraction? Or is it greater than? There are several ways to do this, but I'm going to do it in a way that provides common denominators. So there's kind of a trick. I see that the second denominator, or the denominator of the second fraction is 4. I'm going to multiply the first fraction by 4/4. and get an equivalent fraction. I get 24 over 60. I'm going to multiply since the denominator of the first fraction is 15, I'm going to multiply the second one by 15 over 15. So I'm multiplying each fraction by the other's denominator. And we get 45 over 60. So now that they have the same denominators, they're easy to compare. 24 60ths, 45 60ths. 45 is the larger one, so I'm going to write my inequality symbol like that. Let's try this next one. We have 28 30ths and 7 eighths. So I'm going to grab a calculator for this. I'm going to multiply this one by 8 over 8 and this one by 30 over 30. And let's see what we get. 8 times 28 is 224. And 8 times 30 is 240. We get some big numbers doing it this way sometimes. 7 times 30 is 210. And 8 times 30 is 240 again. But now, no matter how big the numbers are, they have the same denominator. We can see that 224 is greater than 210. All right, so the first fraction is greater than the second fraction. So that's true of these also. So, as I mentioned, there are several other ways. You can find the decimals of both fractions. That's an easy way to do it. There's a cross-multiplying way. But, like I mentioned, I want to focus on common denominators. So, I'm going to multiply this one by 9 and this one by 2. 9 times 3 is 27. 9 times 2 is 18, so that's equivalent to 27 eighteenths. 12 ninths, if I multiply top and bottom by 2, is going to be equivalent to 24 eighteenths. The first fraction wins. It's bigger than the second one. So 3 halves is greater than 12 ninths. All right, let's give these a try. These are our last examples. We have 5 ninths and 4 sevenths. So I'll multiply each fraction by the other fraction's denominator. So this one by 7, and the top and bottom. This one by 9. 5 ninths becomes 35 over 63. And 4 sevenths becomes 36 over 63. This was a close one, but the second fraction is larger. All right, 2 ninths and 1 fourth. This one we're going to multiply by 4 over 4. That becomes 8 over 36. And this one by 9 over 9. That becomes 9 over 36. 9 36 is greater than 8 36, so the inequality symbol goes that way. 2 ninths is less than 1 fourth. All right, we talked about several important things: equivalent fractions, reducing fractions, and comparing fractions. That was a giant step. All right, hope it goes okay for you.